Hey everyone, hope you're all doing very well. Welcome back to another video here on the channel. In today's video, we're going to be taking a look at frame rates with servos. Now this is a video that I wanted to do over a month ago. However, I was waiting for a couple components to come in so that I can decide how I want to show this in order to see exactly what frame rates are actually coming out of our receiver. We're going to be able to measure that here very shortly. And if you watched the last video that we did, you would see that we had a couple components arrive. Now you only got to see the one item last week. However, that same item would be able to do what we're doing here in this video. Today, what we're going to be looking at is a component from the same company, from Fnirsi. I'll leave a little description here on how you can properly pronounce this word because I'm not saying it correctly. However, this model is the DSO 510, and it is essentially a mini oscilloscope as its primary functionality, but it can act as a signal generator, which is really cool too. You can actually drive components based off of this signal generator that is included with this exact unit. Now what we're going to do with this unit is we're going to measure the actual waveforms that we're getting from our receiver. You're going to be able to see how the waveforms change as we move within that single channel, and you're also going to be able to see exactly what kind of frame rates are coming out of the specific radio, and of course that should absolutely match the selection that we're making on our transmitters. Now most transmitters have the ability to change the frame rates, and that's ultimately why we're looking into this in this particular video. And just before we get into it, I do want to thank the Tier 1, Tier 2 Patreon members. Thanks a lot for your continued support. I do have another battery pack that is coming in the mail. However, I do believe this is also stuck with the Canada Post strike. They have been now shipping things for quite some time already. I should be able to see that very shortly, I hope. So stay tuned for that video when I'm able to receive the pack and get that tested as well. Now, what we're going to do here in this video, I'm going to go through it in a few seconds. We're going to first talk about the frame rate and why it might be important to you. We're going to go through on how we should actually select the frame rate. How do you know if a frame rate is too low or too high for your specific application? We're going to go through all that, and then we're going to go and see exactly how the frame rate looks on a screen so that we can see its functionality and the actual values that we've selected come to life right there on the screen and measured. And last thing before we get started, you're going to see more of these types of units being used in future videos because I really want to explore the oscilloscope. I've never owned one. I've used one in the past. However, owning one allows us to do some really cool things to check out what is truly going on in the world of RC as it relates to these types of frequencies. So stay tuned for that. Let's jump right into it and start talking about the frame rate. So frame rate is definitely something that you will want to pay attention, especially when we're talking about these advantages that you can get with faster frame rates. Now, when we're talking about frame rates, essentially what's happening when we're talking about faster frame rates is that we're getting more information from our receiver to our servo, and that's ultimately what gives us the advantage. We can talk about that here very shortly. What's actually happening at the transmitter side of things is this is what gives you the ability to make selections here to choose the specific frame rates. Now, your transmitter might already be stuck and locked into a specific frame rate. However, if you do have a more advanced transmitter, this is ultimately where you're going to find the ability to make these changes. Now, we're going to go through this in an example. You're going to be able to see the frame rate being chosen on my specific transmitter. This transmitter is for radio-controlled surface vehicles, and you can do the exact same thing with an air radio as well. So keep that in mind. It does apply to all of RC. Now, when it comes to frame rates, both your transmitter and your receiver have to have the ability to agree on a frame rate that you want to choose. If you're selecting a frame rate, but your receiver can't support that, then you're going to run into issues there and not actually be able to achieve the frame rate that you're after. Now, this can happen if you have a newer transmitter and you're trying to get that transmitter working with an older receiver of the same brand, of course. However, that doesn't have the right version or the latest receiver technology, and that might be hardware based. Now, once you have an idea that these components are compatible, the next step is seeing if your servo is also compatible with these frame rates. Now, typical frame rates have been around 20 to 22 milliseconds, which really represents around the 45 to 50 hertz. I'm going to throw a chart up on the screen, so every time we're talking about milliseconds or frequency, you can use this chart to correspond the other value if I'm not stating that. When we're talking about 22 milliseconds or so, this is essentially your box stock transmitter. if it's operating at 22 milliseconds, it's going to be able to work with all types of servos. That's a pretty standard and general thing. Now, there are some transmitters that don't offer 22 milliseconds. You might be looking at something closer to the 12 to 15 milliseconds for a newer style of radio, and we'll get into that as well here. Ultimately, when it comes to servos, you're going to have two different types of servos. You're going to have an analog servo and you're going to have a digital servo. And when it comes to frame rates, there's a massive difference between both of these types of servos. Your analog servo is not going to be able to handle the frame rates that your general and typical digital servo will be able to handle. And ultimately, when we're talking about these frame rates, the best thing to do is to look at the manual or specifications of your specific servo and brand of servo in order to get the maximum frame rates. This is, of course, the fastest frame rates that is acceptable with your servo. And when it comes to analog servos, the general idea is about 14 to 22 milliseconds is going to be the range that those are going to work at. Regardless of any type of specification, we're going to look at what happens if those don't exist. But ultimately, when it comes down to this type of specification, what I do recommend is reach out to the manufacturer if they don't post it. Otherwise, if you can't find this information, then you subject yourself to some risk, and we can go through how to mitigate the risk, but it's not going to be a guarantee, making certain that we don't take out one of the servos in this type of process. Now, when it comes to digital servos have a very wide range of operation as your typical general servo. Anywhere from that 22 milliseconds that we talked about being your box stock setup, all the way down to about 3 milliseconds, maybe even faster too. I've not tested beyond the 3 millisecond frame rate. Now, also what I want to mention here is that I have not found a digital servo that cannot withstand 3 milliseconds. I'm sure there is one out there, and we're going to go through the process in order to make certain that everything is okay, to the best of our ability here very shortly. But I do want you to know that I have not tested one and found one that does not handle 3 milliseconds. Now we're going to take a look at what happens as we adjust the frame rates. You're going to see a servo that operates really well, a digital servo that operates really well at a low frame rate, a fast frame rate, and you're going to see an analog servo, of course, because all my digital servos operate fine on this frame rate, but the analog servo is going to have some trouble and it's going to struggle, and you're going to see all of that. And essentially, I almost burned this servo out because I ran the test for too long, and they do heat up very quickly. So that's one spoiler. Let's jump into it to see exactly what happens here. Here we have the two servos and we have our oscilloscope. The oscilloscope is showing us that there's a period of 14 milliseconds, and then on that side we can see 71 hertz. And you can see, of course, the graph corresponding to that. Now, what I want to do is take this from a 14 millisecond signal and I want to up that rate. So we go over to our transmitter here, and we're using the radio link transmitter. We go into 14 milliseconds, and we're going to access 3 by selecting 3 milliseconds. And now that's already updated. The first thing I'm going to do is I'm going to go and hit this auto mode so we can get this to look a little prettier. It's going to go through its auto cycling in order to get us a better picture here. And we wait for that, and once it's up, there's what it looks like. And you can see the image. You can also see that our information has been updated. We got 3 milliseconds for the period, and on the top left it says 333 hertz. So everything looks really good. Now, what's unique about our servos right now is we got a really fast rate of speed, and our analog servo is seeming quite happy, but I can guarantee you this is not. And we're going to see just when I start to rotate the steering wheel here on our transmitter. So let's go ahead and do that and pay attention to the motion that these servos go through. We can already see a little bit of inconsistent motion and movement from that analog. Oh, it looks like it's stuck. And there it's snapping back. And then we go to the left, it's snapping a lot. It's not very smooth. And watch me come to a stop here. It's not moving. The other arm, you can see it's moving. And then it starts to move. I'm going to come to a stop. You can hear this thing buzzing when I touch it. It's significantly buzzing and vibrating. So this would be a clear indication that this servo is not going to be working with this type of period and frequency. It's not made to handle this type of refresh rate. But the digital servo at this refresh rate seems to be totally fine. So there you have it, a few things to watch out for. Any abnormal movement or motion within the servo, if it's jittering, if it's stuttering, if it's just, jumping to certain positions, and especially if it's overheating. Those are the major things to look out for. Anything abnormal essentially is going to be a good indicator to you that something's wrong and you should go and move to a slower frame rate. If you're not comfortable with that and you want to reduce your risk a little bit further, what we can do, instead of going with 3, 4, 5, 6 millisecond frame rates, go to the more moderate section of frame rates. You're still going to enjoy the better precision and the faster response time of that digital servo. However, it's going to be a little bit slower than its absolute maximum according to your transmitter or the settings that you can actually apply. And what I would highly recommend is selecting a frame rate that is somewhere between 8 milliseconds and 12 milliseconds. And of course, the slower the frame rate that you end up using, the lower the amount of overall risk. You just won't see the added benefit. There's no essential disadvantage to going with a slower rate other than the benefits in terms of the precision and the response time that you get out of that digital servo. Well guys, that pretty well does it for this video. Leave a comment in the section below if you have something to add or a question about what we're talking about here in this video. As always, like the video if you do. Don't forget to hit that sub button so that I can see you guys in the next video. Thanks a lot for watching. See you in the next one.